Here are the major parts of a land, jackup, platform, or submersible rig's blowout prevention equipment. The blowout preventer, or BOP stack. The driller's BOP control panel. The BOP operating unit accumulator. The choke manifold. The choke control panel. The mud gas separator. The flare line and flare pit. The trip tank. And drill string valves. From this BOP control panel, the driller opens and closes, or controls, the blowout preventers and the line to the choke manifold. Rig builders usually place the control panel on the rig floor, close to the driller's position. Levers and switches allow the driller to quickly open and close the preventers and other valves in the system. The accumulator bottles store or accumulate hydraulic fluid under very high pressure, up to 3,000 psi, over 20,000 kilopascals. This high-pressure fluid ensures that the preventers close very fast. The BOP operating unit accumulator is installed some distance from the rig floor. When the driller activates the BOP operating unit, it pumps the hydraulic fluid through the high-pressure pipes or lines into the BOP stack. The hydraulic pressure opens or closes the preventers. Usually, the driller operates the accumulator from the control panel on the rig floor. In an emergency, however, crew members can operate the BOPs by using the control valves on the accumulator itself. Here's a choke manifold. Flow gets to it from the BOP stack via a choke line. The manifold usually has 2 or more special valves in it called chokes. Usually well flow goes through only one of the chokes. The others are backups, or used under special conditions. By adjusting the size of the opening in the choke, making the opening larger or smaller, the driller adjusts the amount of flow through the choke. The smaller the opening, the less flow. The larger the opening, the more flow. The less flow, the more back pressure on the well. The more flow, the less back pressure on the well. This adjustment of back pressure keeps the pressure on the bottom of the hole constant, so that no more kick fluids can enter the well. The driller or another crew member uses the choke control panel to adjust the size of the choke's opening as kick fluids flow through it. By watching the pressure on the drill pipe and casing, and by keeping the mud pump at a constant speed, the choke operator can adjust the choke to keep the pressure on the bottom of the hole constant. The choke operator must keep the bottom hole pressure constant to successfully control and circulate a kick out of the hole. Often, kick fluids in mud from the choke manifold go through a line to a mud gas separator. Frequently, formation gas is the main part of a kick. However, kick fluids may also contain water, oil, or a combination of these fluids. In any case, the mud gas separator removes the gas from the mud. With the gas removed, the pump circulates gas-free mud into the mud tanks and back down the hole. The separated gas goes to a flare line. In the separator, mud with gas in it from the choke manifold enters the top and falls over several baffle plates. The gas breaks out of the mud as it falls over the baffle plates and goes into the flare line. The gas-free mud falls to the bottom outlet, where it goes to the mud tanks for circulation downhole. The flare line conducts gas from the mud gas separator to a flare pit on land rigs. The gas is burned or flared at the flare pit. Notice that the flare line outlet is a good distance away from the rig floor, so even while gas is flaring, the crew can still safely work on the rig floor. Offshore, where there's no flare pit, the flare line conducts the gas over the side of the rig. The line runs over the water, a safe distance away from the rig. A trip tank is a special mud tank. It is used when they pull drill string from the hole. For example, to change out a dull bit. They also use a trip tank when they run drill string back into the hole. Pulling the drill string and running it back in is called a trip, which is why they call this small tank a trip tank. They use it to keep accurate track of how much mud the drill string displaces in the hole. When the crew pulls drill string from the hole, the mud level in the hole drops. If they let the mud level drop too far, it won't exert enough pressure to keep formation fluids from entering the hole. So, as the crew pulls pipe, they continually circulate fluid from the trip tank to replace the drill string and keep the hole full. They also watch for unusual changes, and they make sure that the volume of mud they put in exactly replaces the volume occupied by the drill string. Since the volumes are small, the level of mud in the trip tank is calibrated in small increments, such as stands of pipe, or barrels, or liters of mud, or both. If the volume they put in is less than the volume occupied by the drill string they removed, then it's likely that formation fluids have entered the hole. For example, let's say the crew pulls 1 stand of drill pipe. In this instance, the stand displaces 0.7 barrels or 111 liters. Therefore, they should pump 0.7 barrels or 111 liters of mud to replace the stand. The mud level in the trip tank should show a drop of 0.7 barrels or 111 liters. If the level in the tank shows less, then formation fluids have entered the hole, and the crew must take steps to control the well.